Welcome to Max online class. So far we have seen how to test a function by using a vertical line test. Now let us discuss about the topic representation of functions. A function may be represented by a set of ordered pairs, a table form, an arrow diagram, a graphical form. Let f a tends to b be a function, set of ordered pairs. The set f is equal to set of all x comma y such that y is equal to f of x comma x belongs to a. Of all ordered pairs represent a function. Table form. The values of x and the values of their respective images under f can be given in the form of a table. Arrow diagram. An arrow diagram indicates the elements of the domain of f and their respective images by means of arrows. Graph. The ordered pairs in the collection f is equal to set of all x comma y such that y is equal to f of x comma x belongs to a are plotted as points in the xy plane. The graph of f is the totality of all such points. Exercise 1.4. Second sum. Let f a tends to b be a function defined by f of x is equal to x by 2 minus 1, where a is equal to set of all 2, 4, 6, 10, 12. B is equal to set of all 0, 1, 2, 4, 5, 9. Represent f by set of ordered pairs, a table, an arrow diagram, a graph. Here the values of a and values of b are given, and the function is also given. First you have to find the values of function for each value of a. Let us take the first value of a. The first value is 2. Now substitute x is equal to 2 in the function. Then f of 2 is equal to 2 by 2 minus 1, which is equal to 1 minus 1 equal to 0. Substitute x is equal to 4 in the function. So f of 4 is equal to 4 by 2 minus 1 equal to 2 minus 1 equal to 1. Substitute the third value. The third value is 6. Now substitute x is equal to 6 in the function. So f of 6 is equal to 6 by 2 minus 1 equal to 3 minus 1, which is equal to 2. Now substitute x is equal to 10 in the function. So f of 10 equal to 10 by 2 minus 1 equal to 5 minus 1 equal to 4. Finally, substitute the last value x is equal to 12 in the function. So f of 12 is equal to 12 by 2 minus 1 equal to 6 minus 1 equal to 5. Set of ordered pairs. Now write all the elements in the form of ordered pair. F is equal to set of all 2, 0, 4, 1, 6, 2, 10, 4, 12, 5. Table. Construct a table like this. In this table, write first x and then f of x. Then x values are 2, 4, 6, 10, 12, and their corresponding values are 0, 1, 2, 4, 5. Arrow diagram. Consider two sets A and B. In these two sets, copy the elements from A and copy the elements from B. In A, the elements are 2, 4, 6, 10, 12. And in B, the elements are 0, 1, 2, 4, 6, 9. By using ordered pair and table, we can represent in the arrow diagram. So 2 as 0, 4 as 1, 6 as 2, 10 as 4, 12 as 6. Graph. The points are 2, 0, 4, 1, 6, 2, 10, 4 and 12, 5. First draw the horizontal and vertical line. First plot the first point 2, 0 and then plot the second point 4, 1. Plot the third point 6, 2. And the fourth point 10, 4. Finally the last point 12, 5. Now join all the points. Join all the points. Ninth sum. If the function f is defined by f of x is equal to x plus 2 if x greater than 1. 2. If minus 1 less than or equal to x less than or equal to 1. X minus 1. If minus 3 less than x less than minus 1. Find the value of f of 3, f of 0, f of minus 1.5, f of 2 plus f of minus 2. Consider a number line. Functions are defined by 3 parts. For a better understanding, function is defined by 3 values in the intervals 1, 2 and 3. The first interval is x greater than 1. X greater than 1 means the value of x is 2, 3, 4, 5, 6, etc. And the second interval is minus 1 less than or equal to x less than or equal to 1. So here x lies between minus 1 and plus 1. The third interval is minus 3 less than x less than minus 1. The third interval lies between minus 3 and minus 1. F of 3. Here given value of x is 3. So find out the interval at which the point 3 is located. Here 3 is located in the first interval. So f of x is equal to x plus 2. Now substitute x is equal to 3. F of 3 is equal to 3 plus 2 which is equal to 5. Second sum. F of 0. 0 is located in the second interval. So the function is f of x is equal to 2. Now substitute x is equal to 0. So f of 0 is equal to 2. Subdivision 3. F of minus 1.5. Minus 1.5 is located in the third interval. Its function is f of x is equal to x minus 1. Now substitute x is equal to minus 1.5 in the function. So f of minus 1.5 is equal to minus 1.5 minus 1 equal to minus 2.5. Subdivision 4. F of 2 plus f of minus 2. Here two numbers are combined together. So consider the first one, f of 2. 2 is located in the first interval. Its function is f of x is equal to x plus 2. Now substitute x is equal to 2 in the function. So f of 2 is equal to 2 plus 2 equal to 4. F of minus 2. Minus 2 is located in the third interval. Its function is f of x is equal to x minus 1. Now substitute x is equal to minus 2. So f of minus 2 is equal to minus 2 minus 1 which is equal to minus 3. Now add f of 2 and f of minus 2 which is equal to 4 minus 3 equal to 1. Third sum. If f of x is equal to 2x minus 1, comma, g of x is equal to x plus 1 by 2, show that f dot g equal to g dot f is equal to x. Here two functions are given, f of x and g of x. But you have to verify f dot g equal to g dot f is equal to x. First you have to find out f dot g. F dot g is defined by f of g of x. Now replace g of x is equal to x plus 1 by 2. So it becomes f of x plus 1 by 2. In the function of f of x, replace x is equal to x plus 1 by 2. It becomes 2 into x plus 1 by 2 minus 1. Now cancel 2 and 2. So it becomes x plus 1 minus 1. Plus 1 minus 1 cancelled. Then you have x. So f dot g equal to x. Similarly, we want to prove g dot f is equal to x. So you first consider g dot f, which is equal to g of f of x. Now substitute f of x is equal to 2x minus 1. So you have g into 2x minus 1. In the function of g of x, you have to replace x is equal to 2x minus 1. So it becomes 2x minus 1 plus 1 divided by 2. In the numerator, plus 1 minus 1 cancelled. Now you have 2x by 2. Cancel the numerator and denominator by 2. Then you have x. G dot f is equal to x. Now you have f dot g is equal to x. G dot f is also x. So it is proved. Fourth sum, subdivision 1. F of x is equal to x square minus 1, comma, g of x is equal to x minus 2. Find a if g dot f of a is equal to 1. Here two functions are given and the condition is also given. So the two functions are f of x is equal to x square minus 1, comma, g of x is equal to x minus 2. First you have to find out g dot f of x, which is equal to g f of x. Substitute f of x is equal to x square minus 1. So it becomes g into x square minus 1. In the function of g of x, you have to replace x is equal to x square minus 1. So it becomes x square minus 1 minus 2. That is equal to x square minus 3. Now g dot f of x is equal to x square minus 3. Now substitute x is equal to a. So you have g dot f of a is equal to a square minus 3. But the condition is g dot f of a is equal to 1. Now you have to substitute g dot f of a is equal to a square minus 3. Now you have a square minus 3 is equal to 1. You bring a minus 3 to the other side, it becomes positive. So you have a square is equal to 3 plus 1. 3 plus 1 is equal to 4. Now taking a square root on both sides. So you have a is equal to plus or minus 2. Subdivision 2. Find k. If f of k is equal to 2k minus 1 and f dot f of k is equal to 5. Here one function is given, that is f of k is equal to 2k minus 1, and the condition is f dot f of k is equal to 5. You make use of f dot f of k is equal to 5. First you have to find out f dot f, which is equal to f dot f of k. Now substitute f of k is equal to 2k minus 1. Then you have f of 2k minus 1. In the function of f of k, you have to replace k is equal to 2k minus 1. Then you have 2 into 2k minus 1 minus 1. Multiply the 2 inside the bracket. So you have 4k minus 2 minus 1, which is equal to 4k minus 3. but the condition is f dot f of k is equal to 5. Now you have to substitute f dot f of k is equal to 4k minus 3. If you substitute, you will get 4k minus 3 is equal to 5. Now you bring the 3 to other side. So it becomes positive. So 4k is equal to 5 plus 3. 5 plus 3 is 8. So 4k is equal to 8. Then k is equal to 2. The value of k is equal to 2. Thank you. Fifth sum. Find the area of the quadrilateral whose vertices are at subdivision 1 minus 9 comma minus 2 minus 8 comma minus 4 2 comma 2 and 1 comma minus 3. Here 4 vertices are given to you. We want to find the area of a quadrilateral. First of all, you have to plot all the points in a graph. For that, draw horizontal and vertical line and then write the numbers on the horizontal and vertical line and then plot the points. Plot the 4 points. First point is minus 9 comma minus 2. Second one is minus 8 comma minus 4. 1 comma minus 3. 2 comma 2. Plot all the points and join all the points. Afterwards, in the third quadrant, this is first quadrant, second, third, fourth. First, second, third, fourth. In the third quadrant you have to take the vertex A. Third quadrant you have to take the vertex A. In quadrilateral, in third quadrant you have to take the vertex A. A, B, C, D, counterclockwise direction. A, B, C, D. So let the vertices A is equal to minus 9 comma minus 2, B minus 8 comma minus 4, C 1 comma minus 3 and D 2 comma 2. Then find the area of a quadrilateral. First you have to write the formula. Area of a quadrilateral is half into x1 y1 x2 y2 x3 y3 x4 y4 x1 y1. First vertex is x1 y1. This is x1 y1, x2 y2 x3 y3 x4 y4. This is x1 y1 x2 y2 x3 y3 x4 y4. Just substitute the values in the formula. So half into minus 9 minus 2 minus 9 minus 2 minus 8 minus 4 minus 8 minus 4 1 minus 3 1 minus 3 2 2 minus 9 minus 2. Just substitute all the values in the formula, then multiply half into, first multiply up to multiply, cross multiply, minus into minus, plus 9 4s are 36, 9 4s are 36, then minus into minus, plus 8 3s are 24, and then 1 into 2 2, 2 into minus 2 minus 4, 36 plus 24 plus 2 minus 4, then put minus sign. Afterwards multiply this direction, minus into minus, plus 2 8s are 16, plus into minus minus, 1 into minus 4 minus 4, then 2 into minus 3 minus 6, minus 9 into 2 minus 18. Then add these three numbers and then subtract the fourth one. Half into 58 minus of minus 12. Here minus into minus, plus half into 58 plus 12. 58 plus 12 70. Half into 70. Cancel the numerator and denominator by 2 table, then you have 35. So area of a quadrilateral is 35 square units.